Welcome to my screencast. My project is about explanatory web document which using linking data to support information on web page for users. So a web application was mainly built in these projects to support searching for users and then return the information which not only mentioned on one web page, but also some related information from other resources. And it will also quickly navigate users to some useful resources due to their preference by doing the information filtering. So this is the homepage of the application, which provides two formats of information that can be processed for searching. Now let's start as a plain text. From the searching box, we can input either the searching item itself or a sentence. So if we input a sentence, then it will extract the keywords within the sentence that can be regarded as the search items. So this functionality was implemented by two approaches, which one is the tokenization and stop word removal. It will tokenize the sentence into many tokens and remove the stop words, or we can say the meaningless words, but it's not actually performed well in the real world. For example, we got two stop words and a part of the sentence. Then for the stop word removal, we'll get the keywords which are the university and Manchester. But in some cases, we expect the University of Manchester as a better result. So the stop word removal is not suitable for all the cases. Then the second approach was introduced in this application, which is used the API called Stanford Named Entity Recognizer. It extracts the keywords in three classes, which are the person, location, and organization. Then we can click for searching, and the information will be returned. So, what information should be represented in this result page? We have to discuss the DPDA structure first. This is a typical DPDA resource page of a specific items. All the information related to it was stored in the RDF triples and shown in this page. As you can see, the information is either the literal, which just from the page itself, or maybe the UIs of other resource page. So for the direct result, which will give some basic explanation of the items, I chose the abstract as the property retrieved for give some basic introduction. And then for the second part, which is recommend some related information from other resources, it's just to extract some specific properties that was highly match users' needs and return the information from its linked resource page. Here also has a graph-based example, which every node was represented by the different resource page, and they are linked together by some special relationship, which is actually the properties in the DPDA database. So for one search items, the information cannot be only retrieved from its own resource page, but also get some related information from its linking resource page. However, some properties are not available for all of the items. For example, only person will have the birth date but not place. So in order to search all of the items, some global properties need to be considered, and finally, the categories was decided. It is also called the subject in the DPDA properties. The categories contain all the related resources of the search items, and then categorize them into the different categories. The users can choose the area they're really interested in and then quickly navigate them to the useful resources that they're interested. However, the recommendation is not obvious due to the widely range of the categories, but you can also do some specific recommendation when searching specific type of items, as the only difference is to retrieve the different properties. And then we can write the Sparkle queries to extract the values of the RDF triples. Now, let's choose one of the options, and then we can get more informations. Instead of representing the informations like the previous results, I use the Google Customer Search API to build a search engine in my own application so that the website and the images set was related to the search items and the resources in this area will be returned, like the Google search, so that users can browse all these informations. And if you click on it, it will direct you to the website. And for the URIs format, you can tap the URIs of the web page, and then it will return the main text body of that web page. And you can do the same process as the previous option. You also have a feedback session that you can tweet all your comments, and I will collect the data and doing the improvement in the future work. So here's the whole work of my project. Thanks for watching and hope you enjoy it.